Okay, Wildcats. Today we're looking at Thursday, February 8th, rational function transformation on page 54. Now you're probably wondering why you see the fifth 6 weeks on table of contents. Well, let me update you why. Okay, test 7, which is on February 7th, will be the last grade of the fourth 6 weeks. Okay, so with that, now we're moving on to the fifth 6 weeks, and we're looking at rational function transformations on page 54. So if you would, update your table of contents. All right. So now your table of contents is updated. Let's take a look at the notes. Now, the note should look familiar. Transformations are the same with all functions. So now we're looking at them with respect to rational functions. Okay, so when the negative is in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is inside of the parentheses or in front of the b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. And then I'll go into more detail with asymptotes as we go through examples, but just know that the vertical asymptote is x equals h, and the horizontal asymptote is y equals k. All right, so now let's take a look at the examples. All right, example 1. Now we're going to start off with not doing any transformations. We're going to look at the parent function first, okay? So the parent function of a rational function is y equals x. So the transformation is that it's the parent function. Okay. Now, to graph it, let's look at some x and y values of the function y, or 1 divided by x. Okay, so let's look at when x is negative 1. 1 divided by negative 1 is negative 1. When x is 0, 1 divided by 0 is undefined. Okay, and that's kind of when the asymptotes, and that's why we have asymptotes for rational function, because 0 makes the value undefined. Okay, and then when x is 1, 1 divided by 1 is 1. Okay, so what you want to do in a rational function is first graph the asymptotes. So since we know at x equals 0 is undefined, we have an undefined dashed line at x equals 0. So your vertical asymptote is x equals 0. Now, because the y value at x equals 0 is undefined, you have a y asymptote at 0. So I guess I can put it right here, y equals 0. Okay, so now let's graph those points. So when x is negative 1, so our vertex, well, actually these are points, so we go negative 1, negative 1. Now, what that point tells us is where the curve lies, okay? We know in a rational function, it curves next to the asymptotes, okay? If the dot was here, the curve would be here. Okay, so now 1, 1 is right here. That tells us that the curve is right here, okay? All right, so for our domain, we go from left to right. So our domain is from negative infinity. It's undefined at 0, so negative infinity to 0, and then from 0 to infinity. And basically, that tells you that the asymptote is at x equals 0. Now the range is from bottom to top, so we go from negative infinity to 0, because it's undefined at 0, and then 0 to infinity. All right, so for the x-intercept, if it's an x-intercept, f of x equals 0. So that's 0 equals 1 divided by x. We cross multiply and solve, so x times 0 is 0. Technically, we can put a 1 there, so 1 times 1 is 1. 0 does not equal 1. So we know that there are no x-intercepts. All right, so for the y-intercept, if it's a y-intercept, the x value equals 0. So that's, and I'm only going to write this once, but f of x is equivalent to y. So we have y equals 1 divided by 0, which is undefined. Okay, so there are no y-intercepts. Which makes sense because that's where our asymptotes are there. Okay, so now we're going to apply the same concepts to the transformation. The only thing we're going to do is move the vertex, which moves the asymptotes. Okay, now understand that rational functions, there's a lot to take in, so if anytime you get frustrated and you want me to go over these examples again in class, I can do that, okay? All right, example 2. So first thing, we're going to move the vertex. So that tells us we move the vertex to the right 2. Okay, so that means our new vertical asymptote is x equals 2, which makes sense because 2 minus 2 is 0. 1 divided by 0 is undefined. Now, there's no vertical transformation, so then our horizontal asymptote is still at y equals 0. So our asymptotes are x equals 2 and y equals 0. All right, so now to graph, we want to graph by direction. So we know the directions are -1, -1, 1, 1. So from the vertex, and a vertex in a rational function is the center of the asymptote. So from here we go left 1, down 1. Oh, wait a second. I was about to make a mistake. I forgot that we have a negative here, so we actually have to multiply these, the y values, by -1. So -1 times -1 is a +1, and 1 times -1 is a -1. Now, if you ever make a point with a marker, you can just put an X over that point. Okay, and that tells you that point is not the correct point. So now that we've multiplied by -1, our new directions are left 1, up 1, and we go right 1, down 1. And so again, those points tell us where the curve is. All right, so our domain. Our domain is from -infinity to +2, and then 2 to infinity. Okay, and then our range is from -infinity to 0, and then 0 to infinity. And those basically, that's telling you that there's an asymptote at x equals 2 and an asymptote at y equals 0. All right, so our transformations, we reflect over the x-axis, and we are going to the right 2 units. All right, So for the x-intercept, we know that f of x equals 0. So then that's 0 equals, and I'm going to move the negative up here, so negative 1 divided by x minus 2. Now, I can divide any number I want by 1. And the reason I'm going to do that is so I can cross multiply. 0 times x minus 2 is 0. 1 times 1 is negative 1. Since 0 does not equal negative 1, there are no x-intercepts. All right, so for the y-intercept, x equals 0. So then, and remember, f of x equals y. So y equals negative 1 divided by 0, negative 2. Negative 1 divided by negative 2 is 1/2. So our y-intercept is 0, 1/2. All right. So now let's move on to example 3. All right. So first things first, we want to move the vertex. So we go left 1, down 3, 1, 2, 3. So that's where our new asymptotes are. So we have an asymptote at x equals negative 1, which makes sense because negative 1 plus 1 is 0. 2 divided by 0 is undefined. And then we went down 3. So 1, 2, 3. All right. So then that is y equals negative 3. So our asymptotes are x equals negative 1, y equals negative 3. All right, so the next thing we want to graph by direction. So we know it's negative 1, 1, 1. And we know that we're not multiplying. Oh, wait. I'm glad I looked. We are multiplying by 2, so we need to multiply the y's by 2. So negative 1 times 2 is negative 2, and 1 times 2 is 2. So our vertex is the center of the asymptote. So from here we go left 1, down 2, and that tells us our curve is here. And then we go right 1, up 2, and so that tells our curve is here. All right, so our domain is from negative infinity to negative 1, and then negative 1 to infinity. And then our range is from negative infinity to negative 3, and then negative 3 to infinity. All right, and our transformations are left 1 unit, it's a vertical stretch of 2, and then down 3 units. All right, so our x-intercept, again, if it's an x-intercept, f of x equals 0. So we have 0 equals 2 divided by x plus 1 minus 3. So we add 3 to both sides, so we get 3 equals 2 divided by x plus 1. And again, I'm going to divide this by 1 so I can cross multiply. So then I get 3 times x is 3x, 3 times 1 is 3, so that's 3x plus 3 equals 2 times 1 is 2. So then we subtract 3, that's negative 1 divided by 3, so x equals negative 1 divided by 3. So your x-intercept is negative 1/3, comma 0. All right, so for our y-intercept, x equals 0. So y equals 2 divided by 0 plus 1 minus 3. So that becomes 2 divided by 1. 2 minus 3 is negative 1. So your y-intercept is 0, negative 1. All right. So now let's look at example 4. All right, so example 4. First things first, remove the vertex. So that means we go to the right 3. So 1, 2, 3. So our new vertical asymptote is x equals 3. And there's no vertical transformation, so our horizontal asymptote is at y equals 0. So our asymptotes are x equals 3, y equals 0. All right, so now we want to graph by direction. So we know it's negative 1, negative 1, 1, 1. But here, we're actually multiplying the a value by 1/2. Okay? Okay? So that becomes negative 1/2, and that becomes positive 1/2. Now, one of the things, whenever you're like, something looks odd or unique, and you're like, well, I think I did it right, but I'm not sure, I recommend using your calculator to check that. So let's go ahead and graph example 4. So let's do control divide. 1 divided by parentheses x minus 3. And what we're checking for is we want to see if in fact, when we move the direction, negative 1, negative 1/2, we're actually correct. So from the center, I go to the left 1 down 1/2. So that point looks like we're at 2 and 2.5 basically. So let's look if that's true. So control T, and it in fact is. That verifies that our point 2, negative 1/2. And let's see if the next, now we go to the right one, up 1/2. So that's saying we're at 1, 2, 3, 4.5. So if I go 4 and 1/2. So that verifies that those points are incorrect and that we multiplied the direction correctly. Okay. So then that point tells us where the curve is. And so our domain is from negative infinity to 3 and 3 to infinity. And then our range is from negative infinity to 0 and then from 0 to infinity. All right, a transformation. That's a vertical compression of 1/2, and it's a right 3 units. Okay, so for our x-intercept, we know that f of x equals 0, so 0 equals 1 divided by 2 x minus 3. Again, I'm going to divide it by 0 by 1 so I can cross multiply. 0 times 2 times x minus 3 is 0. 1 times 1 is 1. That is not equal, so there are no x-intercepts. Okay, so now for the y-intercept. We know that x equals 0. So then that's y equals 1 divided by 2, 0 minus 3. So then that equals 1 divided by negative 6. So your y-intercept is 0, comma, negative 1 divided by 6. All right, so that was fun and exciting. I don't know, there's something cool about graphing rational functions. Don't know. So with that, you have two options. If you understood our examples, start working on the assignment. Option 2 is if you have some questions, you can wait to class and I'll go over the examples again in class. Okay? So as always, have a wonderful Wildcat